All right. I am recording once again. Just wrapped up that video that you watched on Thursday. Now I'm diving straight into another one. Today is what? Monday. Okay. We're doing lesson 2. Hopefully you did the Canvas assignment. If not, you should catch up on that. I will be back next class period. That will be Wednesday, and we'll do 9.3. There is tutoring today after school, so if you feel like you're not getting enough from these videos, I highly encourage you to go there. I encourage you to look at the notes that Miss Sherwood has posted. There's plenty of resources. I just want you to stay on top of things despite my absence, okay? Today we're talking circumference, which circumference is a specific word for the perimeter of a circle. Last lesson we talked about the perimeter of just anything, right? Which meant to add all the edges together. Well, the edge of a circle is the circle itself, and we refer to that specifically as the circumference. So, that's a lot of the lesson today. So, we're going to think about where does the equation for circumference come from? All right, so I'm not spoiling circumference, the equation for circumference. Maybe you know it, but I'm not going to spoil it, right? We're going to arrive at that answer together. So let's first consider inscribing. There's that word. We saw that in last unit. To inscribe meant to put a shape inside of a circle. So this first one, we have a pentagon inscribed in a circle. How many sides are there? Clearly, there's 5 sides to our pentagon. How many radial triangles are there? Well, a radial triangle means, well, let's draw this with me here. Draw from the center to each vertex for me. And I'm going to make them super nice and straight like I was in the last video. Boom. 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 So to draw these edges, to draw these radii from the center to the edge, how many triangles did we create? 1, 2, 3, 4, 5. Those are referred to as radial triangles. What's the measure of each of those angles? So they're each the same size. This is a regular polygon. I didn't highlight that word here. Let's highlight that word. These are regular polygons, meaning that every side is the same length. This is the same length as that, 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 okay? All 5 sides are the same length. That makes it regular. But as a result, each of these triangles are the exact same. So all 1, 2, 3, 4, 5 angles are the exact same size. So what's 360? 360 degrees in a circle divided by 5. Each of these are 72 degrees. All right, let's speed that up. Draw in your 6 radii. Because this has 6 sides. This is a hexagon. So there's 1, 2, 3, 4, 5, 6 radial triangles. And this time around, 360 divided by 6, each is 60 degrees large. And this is a, oops, I didn't hold that long enough. 1, 2, 3, 4, come on, 4, 5, 6, 7, 8. We've got 1, 2, 3, 4, 5, 6, 7, 8 radial triangles because there's 8 sides, and 360 divided by 8 is 45 degrees. So let's generalize this. So let's consider an n-gon. N-gon meaning we don't know how many sides it has. Does it have 10 sides? Does it have 14 sides? Does it have 200 sides? Does it have 1,000,000 sides? Okay, you can have a shape with any number of sides you want. Let's call the number of sides are n. And what did you notice? The number of sides matches the number of radial triangles. And to find the measure of the central angles, we were taking 360 and dividing by the number of sides, whether it was 5, 6, or 8. Well, the number of sides is n. So let's take 360 and divide it by n. We just generalized what we were doing right there. So, do you notice anything about these shapes? The more sides that we put on the polygon, the closer and closer and closer it got to a circle. So imagine a 100-sided shape. Imagine a 1,000-sided shape. Imagine a side with a shape with 1,000,000,000 sides. It's going to mesh closer and closer and closer to that circle that you're not even going to be able to tell the difference, right? All these teeny tiny sides, it might as well just be a circle. And that's what we're about to do. So, draw a perpendicular bisector to side AB. We're not going to use a compass. Let's just do your best to draw a perpendicular bisector. So straight down. Boom. So we bisected. Actually, I'm not going to draw that box because it's going to get in the way. So boom, boom. Actually, I probably should. I'm going to do it in a different color just so it stands out. So bisected, we split it in half. So those two things are the same size. And perpendicular, meaning we have a right angle. Label the intersection M. Okay, so that's M. And the angles formed at O as an angle 1 and 2. So because we drew in a bisector, we created two small angles. Let's call them angle 1 and angle 2. Angle 1 and angle 2. Let me draw them side by side. What type of triangles did you create? We have some right triangles. That's pretty clear. And what's the measure of AOB? Well, at the moment, this is a hexagon, yeah? It's kind of faded. But it's got 1, 2, 3, 4, 5, 6 sides. So at the moment, AOB, 360 divided by 6 equals 60 degrees. So if that equals 60 degrees, when we dropped this bisector through, right, this entire AOB, this entire angle, right, imagine each of the radial triangles. You don't need to draw these in, right, just like the above, right, there were 6 sides, 6 radial triangles. Each of the central angles was 60 degrees. So I'm going to get rid of those because I don't want those to be a distraction. If AOB is 60 degrees, and when we drop that bisector down through, angle 1 and angle 2 are 30 degrees apiece. So far, so good? You're with me? Trigonometry. It's been a minute. Sine, SOHCAHTOA, SOHCAHTOA, as we said in class. SOHCAHTOA, sine is opposite over hypotenuse. So let's figure out the length of AB. Okay? You can only use trig functions on right triangles. So let's focus our attention on this right triangle. Okay? I'm bolding it. Let's focus our attention on this right triangle. So we know that angle 1 is 30 degrees. So sine of angle 1, so sine of angle 1, in other words, sine of 30 degrees is equal to opposite. What side is opposite of angle 1? What side is opposite? Right, if I'm focusing on that black triangle that I bolded, the opposite side is AM. And what is the hypotenuse? Opposite over hypotenuse. The hypotenuse is from O to A, which is the radius of the circle. So sine of 30 degrees equals AM over R. I'm trying to solve for AB. Are you still with me here? I don't want to lose you. I want you to be like, I want you to get like 80% of this. All right. We don't need to have perfect knowledge of this, but I want you to walk out of this right here and be like, I actually followed that. So hopefully you're okay that this was 60 and we split it in half and that's 30. Why do we care about AM? Well, AM and MB are the exact same size. So if I figure out AM, I just need to double it and that gives me AB. You with me? The goal right here is to find the length of AB. So if I can find AM, I'm just going to double it and that is AB. Well, we practically have an equation for AM. So let's cross multiply. That's AM. What's sine of 30 degrees? That's one of our special right triangles. Sine of 30 degrees is just a half. I'm running out of room here. Let me take this and write it over here. So we had R times sine of 30 degrees equals AM because I cross multiplied. And now let's do a little arrow. Well, that's the same thing as 1/2 times R. So AM is 1/2 times R. But we're trying to figure out AB. So how long is AB? AB is 2 times that. AB is 2 times AM. Right? We just take AM and we double it, and that gives us AB. So that means AB is 2 times 1/2 R. So in other words, AB is just, the 2 and the half cross out, R. Okay? Interesting. Let's do all of that over again, except instead of having a 6-sided shape, let's have an N-sided shape. Okay, so remember, AB here is equal to 2 times AM. AM was this for a 6-sided shape. But what is it for an N-sided shape? Let's look back at this. Where did 30 degrees come from? This you gotta bear with me here. What did 30 degrees come from? we're still going to be in a circle with radius r, right? As far as AM is concerned, the r is staying put, but where did 30 degrees came from? It came from the 60 that then got divided in half. So where did the 60 come from? It came from dividing 360 by 6. Right? It came from dividing 360 by 6. But we divided it by 6. Why? Because it was a 6-sided shape. So for an n-sided shape, we need to take 360 and divide it by n. So, okay, here we go. Where did 60 come from? 360 divided by 6. And I get 60. But for an n-sided shape, we're going to do 360 divided by n. Boom. So this was 60 right here. And then we divided it in half and got 30 for angle 1. It's no longer 60. It's 360 divided by n. So then we're going to take that 360 divided by n. So what do we do with the 60? We divide it in half because of the bisector. Well, what are we going to do with the 360 divided by n? We're going to divide it in half, which comes out to be 360 over 2n. Just believe me. So that's what goes right here. Or in other words, that's the same thing as 2 times r times sine of 180 over n. Because 360 divided by 2 is 180. Are you okay with that? I know I might have lost you a little bit there. But I just want you to think about, what did we do for that one? We took the 60 and divided by 2, which gave us angle 1. And hopefully you're all somewhat all right with the whole sine thing. Opposite over hypotenuse. Well, we no longer have 60. We have 360 divided by n. Is it 10 sides? Is it 100 sides? Is it 1,000 sides? You just take it and divide it by the number of sides. And that gives you that angle, the whole angle. But then we had to divide it in half because of the bisector. So when we divide it by half, we get 360 over 2n. So what happens as you make n really big for that thing? Take a second with a calculator and plug some stuff in there. Sine divided by 180 over 10, or sine of 180 divided by 100, or sine of 180 divided by 1,000. Plug those into your calculator if you got a calculator in front of you. I probably could pull up a calculator, but I don't want to leave the app and lose my place here. So I'm going to leave that on you, and you should see something that it gets closer and closer to the number that's behind you on the wall. 3.14159, yada, yada, yada. It's pi. So we just said that, you know what? As n gets really, 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 really big, that's just pi. 2 pi r. And that is the perimeter of a circle. 2 pi r. Maybe you knew that, maybe you didn't. 2 pi r. Still got the Cafe Rio cup. It's the horchata, but the ice has melted now, so it's more watered down. Still tastes good though. Nice and cold. Nice and cold. Alright, so we did it. 2 pi r. Let's use it. So what's the circumference of this circle? R is 6, so 2 times pi times 6 is 12 pi centimeters. That's the exact, well, I shouldn't put that in quotes. That is the exact result, 12 pi. You can leave it like that, okay? 12 pi, boom. That is the answer. That's a legitimate answer in terms of pi. But if we plug that into a calculator, we can round that to be... Do I have the pi button? Yeah, I do. 37.699. We'll call it 37.7 centimeters. Be comfortable with writing it in both terms, okay? Multiple choice answers, that sort of thing. Just be comfortable with writing it as 12 pi. That's a legit answer, 12 pi. That means 12 times pi. But instead of punching in pi and rounding our decimal, we're just going to leave it simple on the page, 12 pi. And in my opinion, 12 pi is a lot cleaner and nicer looking than 37.7, right? Because that's inaccurate. That's not the exact result. 12 pi is exact. That is 100%, without a doubt, the length of the circle, the circumference of the circle, 12 times pi. And then when you go and round it, you're making it more inaccurate. Just leave it, 12 pi. Now, if the question asks you to round, then of course round. But just know that 12 pi is perfectly fine and probably the ideal answer, in my opinion, ideal. What it is, I didn't even take a second to acknowledge this. Over here, when we have 2 pi r, or 2 times r times pi, doesn't matter what order you write it. What is 2 times r? When you double a radius, what is that? It's the diameter. So if I give you the diameter, boom, you have your 2 times r part. Boom, 9 pi. All right, 2r pi, 2 times r times pi, 2 times the radius is, boom, the diameter. So diameter times pi is your answer. Or you plug that into a calculator and you get 28.3 feet. So the circumference is basically the revolutions of a circle. Okay, so if you were to roll, right, look at this point here. If this were a wheel, or if this were like a toy that was rolling, when it makes one complete revolution, right, as it travels, it's going to, the distance that it travels is the length of the circumference. Imagine you like had chalk on a wheel or something. I don't know if any of you play baseball in the room, but if you had chalk on a wheel, right, there's those things that like put chalk, the foul lines, right, and you just roll it, right? Each revolution, right, the chalk is leaving an imprint. So one revolution, the length, the circumference of the wheel might be, 5 feet. So you just did 5 feet of chalk, and then turn after turn after turn, the chalk keeps laying on the ground. So how far will you have traveled, revolution after revolution after revolution, for 10 revolutions? Well, 12 pi times 10 gives you 120 pi, which is approximately, right? If one turn is 12 pi, then 10 of them, multiply it by 10. And 120 pi times 10, $376.99, which might as well just round up to 377.0 centimeters. And 15 revolutions of this, 9 pi times 15. 9 times 15 is 135 pi, which is approximately 424.1 feet. Okay, so those are pretty, that's very easy to calculate, right? Come on. Give me a break here, right? That's easy to calculate. And a lot of these are super easy to calculate. So let's keep whizzing on through. The Mirny diamond mine in eastern Russia is one of the largest open mines in the world. The mine is approximately circular with a circumference of 3.77 kilometers. What is the approximate diameter of the mine round to the nearest tenth of kilometer? So circumference is equal to 2 pi r. Or pi times diameter. Well, they gave us the circumference, and we're trying to figure out the diameter. So let's not use this one. Let's use this one. Well, if you want to know the diameter, just divide away pi. So circumference divided by pi gives you diameter. Boom. So easy. So the circumference is 3.77 divided by pi. That gives you the diameter. So diameter is 3.77 divided by pi is 1.2. 1.2 kilometers. We're done. Moving on. A roller coaster has two circular loops that have a 15.2 mile radius. Meter radius. When traveling through the loops, the passengers are traveling at a constant speed of 17.8 meters per second. To the nearest centimeter, how far do the passengers travel while looping? So you've got loop. Actually, let's get crazy. So these loops are basically circular, right? So here comes the roller coaster and boom, it hits the circular path and then spits right back out and hits another circular path. So loop-de-loop, okay? Loop to loop, and what does it say? They have a 15.2 meter radius. So there's a 15.2 meter radius for each of these loops of the roller coaster. To the nearest centimeter, don't know why we're asking for centimeters, but to the nearest centimeter, how far do the passengers travel while looping? So this is in meters. So let's do it in meters and then just convert to centimeters in the end, okay? So each of these circles are 2r pi. So 2 times 15.2 times pi, which is 30.4 pi meters. That's one circle. So multiply that by 2 for 2 circles. So that's 60.8 pi meters. Right? I mean, circumference is so easy to calculate. 2 times r times pi. So boom. That's in meters. So does anyone know how to go from meters to centimeters? There is 100 centimeters in 1 meter. So for every 1 meter, that's 100 centimeters. So multiply this by 100 to convert to centimeters. That's 6,080 pi centimeters. Which is approximately 80 times pi. 19,100.9 centimeters. There it is. How long will it take? Does anyone know? How do we do that? If I don't know, you've probably seen this in a science class. Maybe what science classes are you guys in right now? Like chemistry, biology? I don't know what you're in, but probably in like a middle school science class, you saw distance equals rate times time. You've probably heard that. Distance equals rate times time. So if you're trying to figure out how long will it take, well, divide by rate. Distance divided by rate equals time. So take the distance that we traveled. I'm gonna leave it in the whole pi thing. Hope you're okay with that. What did they give us the speed in? They gave us the speed in meters per second. So even though I just converted it to centimeters, I don't want to use the centimeter measurement. Okay, I'm using the meters. If the speed is in meters per second, I need my distance in meters. So the distance that we just traveled is 60.8 meters. Pi, 60.8 pi meters. And we're dividing that by 17.8 meters per second. The result gives us time. So how long did it take? 60.8 times pi divided by 17.8. Those two loops take 10.7 seconds. We're almost done. This is a lot shorter than last time. Ooh, that hat hair though. So, this is fun. What if we don't want to know the whole circumference of the circle? We just want to know a part. We call that arc length, right? Because we've been talking about arcs, right? We're about to take, when I'm recording this, we're about to take our test tomorrow, and we've been talking about arcs and the measurements of arcs and stuff like that, and for unit 8. So what if I want to know the physical distance? We've been talking about the measurement of arcs in the sense of like how many degrees, right? Is that a 30-degree arc, a 60-degree arc, a 100-degree arc, right? We've been talking about more of it in degrees. But what's the literal length? Like if I were to take a string and put it over that arc and then measure it, what's the actual length? That's called arc length. We use a little lowercase s. I don't know who started that, but that's just how it's done. You use a lowercase s for arc length. And this is, look what's in our equation. 2 pi r is in our equation. So that's circumference. But what exactly are we looking at here with measure over 360? So let's answer that question right here. What does the fraction in the equation represent? It represents the portion of the circumference. Or, right, it's the portion of the circumference that we are trying to measure. Right? I mean, and hopefully that makes like hopefully here as we talk about this, that'll make like a lot of sense. Right? If the measure of the arc here is, let's say, 180 degrees. What if we want to find 180 degrees, that arc? Isn't that just half the circumference? Right? That's a pretty easy one to consider, right? 180 degrees is half of a circle. Well, 180 divided by 360 reduces to a half. So we're finding half of the circumference. What if I want to find an arc that's 90 degrees? Hopefully, maybe you know that that's 1/4 of a circle. 90 and 90 make 180. 90 again is 270. 90 is 360. And 90 over 360 gives me 1/4. So I want to know 1/4 of the circumference. So it's just a fraction that helps you figure out what portion of the circumference that you're trying to measure. Right? I don't want all of the circumference. Right? If that fraction didn't exist, we'd just be finding circumference. But do I want to know half the circumference? Do I want to know that arc? Do I want to know 1/4 of it? Do I want to know 1/5 of it? Do I want to know 1/17 of it? I don't know what I'm trying to find. That's why we use the angle. The angle tells us what portion of the circle we want. Do we want half, 2/3, 4/5? How much of the circle do we want? The angle, the measurement of the arc in degrees tells us. So we want 60 of the 360 times 2r pi. So we want 1/6 of 18 pi. So 18 pi is the circumference. I hope you know that, right? I hope you know that after doing it a couple times. 2 times r times pi. The radius is 9. Double that. That's 18 times pi. So 18 pi is the whole circle, but we don't want the whole circle. We want only 60 degrees of it. 60 degrees, well, 60 over 360, that's 1/6 of the circle. So if that arc is 1/6 of the circle, well, then that's 1/6 of the circumference. Boom. So the answer, 3 pi, which is approximately 9.4 centimeters. Again, we know that the circumference of this circle, boom, pretty quickly, it's 12 pi. 2 times r times pi. But we don't want the entire circumference. We only want 45 of the 360, which reduces down to 1/8. If you don't simplify the fraction and you just plug it into your calculator, I'm not going to have a panic attack. But I think it's just nice to see how that simplifies down to like, oh, we just want 1/8 of it, right? 45 degrees, 45 and 9. If you add up 45 degrees 8 times, that gives you a full 360. It's 1/8, which comes out to be 1.5 pi. 12 divided by 8 is 1.5. So 1.5 pi, or approximately 4.7 inches. I'm just plugging it. I have these numbers done ahead of time. I'm just plugging it into a calculator. I mean, just do it. Like if you don't simplify any of this, like it's gonna be more difficult for you to plug into a calculator. Well, not more difficult, but just longer. But you could take look at what's on the page there. 45 divided by 360. There's my 1/8 times 12. There's my 1.5 times pi. 4.7. I don't know if you can see that very well because I'm a tiny webcam in the corner. I don't know how big this is on the projector. 4.7. So boom, you can just plug the whole thing in. How about the one to the left there? 60 divided by 360. It equals times 2 times 9 times pi. Boom. 9.4. Just like I said. So what's this one going to be? 150 out of 360 times 2 times 9 times pi, which comes out to be, let's just go straight to the approximate answer. 150 divided by 360 times 2 times 9. So this is 7 point. So I didn't punch the pi part in yet. I punched in all the numbers and got 7.5 and then pi. So then that's approximately. So I did get the exact answer, 7.5. So 150, let me do it for you again like I was. 150 divided by 360 times 2 times 9 gives me 7.5, as you can see right there, 7.5. I didn't punch in the pi, so 7.5 pi times, so now I punch in the times pi, and I get 23.6 feet. One more time. 225 over 360 times 2 times r times pi. So plug that all into your calculator if you'd like. 225 divided by 360 is 0.625 times 2 times 10. I get 12 and a half. So that's 12 and a half pi. And then I plug that in. I plug in my pi to get my approximate rounded answer of 39.3 miles. Okay, a couple of problems like this, and then we're done. I would compare a problem like this to the problems that we were doing last time, where like we were piecing things together, right? We were saying like, oh, I know how to find this, and I know how to find this, and I know how to find this. So then if I add them all up, boom, right? That's what we were doing. Hopefully that jogs a memory. Well, we're piecing things together here. So this arc is 120, and so is this arc, and so is this arc. Right? These are four circles that are the exact same thing. We're looking at the exact same thing. And tell me, what is 120 plus 120 plus 120 equal? All three of these? 360. So this piece plus this piece plus this piece, those three individual pieces just make one circle. So we want the circumference of one circle, which is 2 times r times pi. What we don't know is what is r. R here, a little tricky. If this distance, well, not super tricky, but if this distance right here is 4, that's from, you could look at that as from here to here. So if this is 4, well then half of it and this other half are 2 and 2 apiece. So the radius is 2. So the circumference is 2 times r, which is 2 times pi, or 4 pi. So that's these blue edges added together. We just found those blue edges, and then these pieces right here, from here to here, here to here, and here to here, are 4 apiece. So all in all, our perimeter is those 3 arcs added together, which gives us one circle, plus those 4 pieces, the 3 pieces that are 4 long, comes out to be 4 pi plus 12. Do not be tempted to add those together and do 16 pi. Okay? They're not the same thing, right? You have 4 pi and 12, not 4 pi and 12 pi, right? If you have 4 oranges and 12 apples, do all of a sudden you have 16 oranges or 16 apples? No, you have 4 oranges and 12 apples. Well, you have 4 pi and 12. They aren't the same thing. They don't combine. So 4 pi plus 12. Which comes out to approximately 24.6. Do we have any units on here? Not really, so we'll say units. Okay, so again, a situation where we have some arcs here. 1, 2, 3, 4 arcs. Well, those 4 arcs are 90 degrees apiece. So we have 360 again. So we just have one circle. And how do you find the circumference of a circle? 2 pi r. So 2 times, what's r? That's something that we don't know yet. Again, just like I drew in that last one, if this whole distance is 11, well, then we need to split it in half here and here. So 11 divided by 2 is 5.5. So 2 times 5.5 times pi gives me 11 pi. So that's one circle, right? That's the 4 arcs added together, or in other words, one circle, plus everything else. The 11 on either side, and the 41 across top and bottom, coming out to be 11 pi plus 144, or 104, which is approximately 138.5, and these are actually labeled to be inches. So yeah, just taking these pieces that, I mean, like I could have given you that individual like arc of 90 degrees, just like we did, right? We didn't do one with 90, whatever. But just, you know, casually, like, oh, there's 60, oh, there's 45, right? 90, but 4 times over. I'm just being clever about it, right? You could have done it. You could have done the 90 degrees and then like said, oh, well, crap, I need to multiply that by 4. We would have got to the same results, okay? But I'm just being clever about it at the start. I'm like, I have 90 here, and 90 here, and 90 here, and 90 here. Oh, that makes 360. That's just one circle. And then add up the rest of the edges that are plainly marked. Okay, this video is a little bit shorter than the last one, which I'm sure you appreciate. I will be in class next time, which will be Wednesday, and that will be lesson 9.3. So on Wednesday will be our lesson, on Friday as the review, and then we'll turn around and have a test next week. This lesson's just 3 lessons, or this unit is just 3 lessons long. So, like I said in the last video, I am holding you accountable for learning this. You've got this great video here that you can go back and watch again. The notes by Miss Sherwood will be scanned in and posted so you can see how she did it. Okay, so you have multiple ways of checking out these notes. You've got your friends around you. You have time right now to work on the Canvas problems. You can do some together. Today is Monday. There is tutoring today after school. You can go hang out after school and work on problems. You've got lots of opportunities, and then I will be in class on Wednesday. Okay? So, enjoy the rest of your day. I'll see you next time. And one last reminder here before I get cut off here. Again, this is what the stream is like. Advertising one more time. This is the last time I'll do it, right? It's the last video. If this feels like, you know what, like he can do all these different colors and he's like zooming in and like pinching in and like talking about things. This right here allows me to do quite a bit with these notes. Like this is not bad at all. It almost would be worth investigating doing this for notes every day. But anyways, if you like this is what the stream is like. We do review problems, and then you can chat live and ask me questions, right? It happens before every quiz and every test. It goes as long as we want it to go. I mean, I try to cap it at about an hour and a half, but we usually don't go that long anyways. So if you like it, come check it out, right? The stream replay is always available. And by the way, this video will be available for you to watch again. I think I already said that, but all right, that's my spiel. Enjoy the rest of the class period. I'll see you next time. See ya.